Hey guys, Mr. Milton here. Today we're looking at multiplying binomials notes. At the end of this video, you should be able to multiply a binomial by a binomial, and you should be able to multiply a binomial by a trinomial. Okay, last lesson, we learned how to multiply a monomial into a polynomial. Today we're looking at how to multiply two binomials together. To do this, we need to multiply each part of the first binomial, so in this case that's 2x plus 3, by each part of the second binomial, and that's x plus 4 in this case. This means we have 4 things to multiply together. Okay, I'll show you 2 ways to do this. Method 1 is called the FOIL method. It's an acronym that represents a process for multiplying. It only works when you're multiplying 2 binomials, though. Okay, so if you tried to do FOIL method with a binomial and a trinomial, the letters just wouldn't stand for what it needs to stand for. Okay, so our binomial in this case, I'll just keep this here, 2x plus 3 and x plus 4. FOIL, F, stands for firsts. So it tells us, hey, make sure you multiply the first. That means you're multiplying 2x times x. When we multiply 2x times x, that gives us 2x squared. O stands for outsides. You're multiplying the outsides together. 2x and 4 on the outside. 2x times 4 gives us 8x. I stands for insides. The number's inside when we put the binomials together. And that's 3 and x. And that's 3x. And then L stands for lasts. So 3 and 4 in this case. And that's 12. Okay, the first step is to multiply each pair of terms together, which we have already done. The second step is to add like terms. Okay, so you'll see our like terms are here. Typically it runs out, we do it like 2x squared plus 8x plus 3x plus 12, and then we'll see like terms here and say, okay, that's 11x. So our answer, 2x squared plus 11x plus 12. Again, remember we can't add these two terms together because although they're both x's, this is x to the second power, this is x to the first. Our second method is called the box method. Okay, and we'll use this a lot, even when we get to factoring. Okay, it's almost like the Punnett square in biology. This method might provide a better visual, but gives the same answer as the previous method, if done correctly. So here, you'll notice that we have the binomial, one going horizontal, one going vertical, and where they meet, their product should be there. So 2x and x meet here, 2x squared. X and 3, 3x. 2x and 4, 8x. 4 and 3, 12. Add our like terms together, 8 and 3x gives us 11x. So 2x squared plus 11x plus 12. All right, so 2 methods to multiply binomial. Here it says multiply each using either method. So here I'm going to do the first one by foiling. I'll do the second one by box method. All right, so we're multiplying firsts, x squared. Outsides, minus 2x. Insides, 5x. Lasts, minus 10. Okay, then I want to combine my like terms, these two terms. Negative 2 plus 5, positive 3. So x squared plus 3x minus 10. All right, second one, I'll use the box method. You don't have to be too fancy with your box. So I have 3x minus 2, 2x minus 1, and where they meet, I'm going to write their product. 3x and 2x, 6x squared. 2x minus 2, negative 4x. 3x minus 1, negative 3x, negative 1, negative 2, positive 2. Okay, these are my like terms. I put them together. I have 6x squared minus 7x plus 2. Okay, either method gets you the same answer if you did them in opposite methods. It's fine. Okay, here we go. Multiplying a binomial by a trinomial. Which of the two methods described on the first page does not work here? That's FOIL. And really, it's only FOIL because like we can't say, okay, firsts, outsides, insides, last. If you think of FOIL as distributing everything to the second term, it can still work. Okay, so which method do we need to use? Box method. I'll show you that after we're done with the box. Okay, I do like the box method here just because there's a lot of information. There's going to be a lot of like terms and unlike terms, and they might not end up right next to each other. Okay, so in my box, I'm going to, and I didn't draw the box last time, so I'm not going to do it. Okay, I'm going to make sure that I have a 3 by 2. Okay, in my 2, 6 in and negative 5. Notice we're taking that negative with that second term. And then here we have 2 in squared, in, and 7. And so we just go through where they meet, that's their product. So 12 and 6, or 2 and 6 is 12 into the third, 2 and negative 5, negative 10 in squared. Okay. In and 6, 6 in squared, in and negative 5 in. 6 in and 7, 42 in, 7 and negative 5, negative 35. Okay. From there, we're looking for like terms here and here, here and here. So we have negative 4 in squared, and we have 37 in. All right, so all of our terms together here, then we have 12 in cubed minus 4 in squared plus 37 in, 37 in minus 35. Organization is key. Like I said, you could do this with FOIL if you chose to, except it wouldn't be FOIL strictly in saying what those words stand for. So you could do 6 in times 2, 6 in times n, 6 in times 7, and then write their products out. And then negative 5 times 2 n squared, negative 5 times n, negative 5 times 7. Write those products out and then circle and find your like terms. Okay, it wouldn't be FOIL per se because it would be more than first, outsides, insides, last, but it would still be the distribution to each term. Okay. All right, let's do some addition and subtraction and multiplication all together here with some polynomials. It says, find the area of the shaded region. Give your answer in terms of x. I like this problem because it makes us a little bit of problem solvers. You want to think about the strategy before you start too deep into this problem. We want to find the area of the shaded region. That's this green part, right? But there's an unshaded region inside of it. So my thought is, okay, if it were just the rectangle, how would I find the area of the entire rectangle? Okay. And I would do that by multiplying the dimensions of it. Base times height, 3x plus 2 times 2x minus 1. But I need to take away this rectangle. Okay, so take away means subtract. I would need to subtract the small rectangle, which is x plus 3, and x minus 1. Okay, so there's our process. This is what we're doing. So now I do need to multiply these things. 3x and 2, 2x and negative 1. Make my box. So I have 6x squared, 4x, negative 3x, negative 2, all that together. That gives me, do this in blue here, 6x squared plus x minus 2. Putting this together, right? Gives me positive 1x. Okay, I need to do something similar with x and 3, x and negative 1. Put their products together, x squared, 3x, negative 1x, negative 3. So that gives me 2x, right? All right, so x squared 2x minus 3. Okay. This is a subtraction problem, but remember from a couple lessons ago, we don't want to do subtraction. I'm going to make this an addition problem. And we can do that, we can make it an addition problem by changing all the signs in the second polynomial. So this will be minus x squared minus 2x plus 3. Okay, and that way we don't have to keep reminding ourselves, oh, do the opposite, do the opposite, do the opposite. Okay, make it an addition problem so we can just do what it says. Okay, 6x squared minus 1x squared gives us 5x squared. X minus 2 gives us negative x, right? And the negative 2 plus 3 gives us 1. And so there we have it. All right, that's multiplying binomials, and see you.